Okay, so I'm assuming a lot of you are writing that Unit 6 test soon. Maybe today.
Ruben Gumiyage, please report to the office. Ruben Gumiyage to the office.
Okay, so I did a part 1 where we went over some concepts in developing the compound angle formulas and double angle formulas. Okay, so this is part 2 of the Unit 6 seminar on trigonometric identities. Today what I am going to do is do a little bit of repetition on the compound angle formulas, because last time I only focused on the cosine law. I want to do a little bit of tan and sine law as well. Then I'm going to go into double angle formulas, especially a question in the unit guide about when you have sine 3 theta, how to solve that, because I know that's a popular test question and something that a lot of people had difficulty on, which is in the latter part of the unit, so sine 3x, for example. I'll show you how to solve that. I'm going to go through sine, cos, and tan, and then I'm going to go through a whole slew of identities just to give you some practice, and when you're doing the identities questions, you can kind of look and see if you understand them. Now, one thing about the test, it is one of the most challenging tests in the course, so don't worry if you're finding Unit 6 very difficult. Unit 7, 8, and 9, and 10 even are quite simple compared to trigonometry. We're getting the hard part over with now, so you're not rushing to learn these concepts in June, which is the way the course was structured before, okay? So don't think that the whole course is going to be as challenging as this particular unit. Okay, so let's get started. I don't know if I did this question in part 1, I can't remember, but it's good practice. So it's the basics of the compound angle formula, and if you're given 2 sine, find sine A plus B if sine A is equal to 3 over 5 and sine B is equal to 5 over 13. So we're going to start with this. Okay, so even though this looks very simple, we have 2 different triangles, triangle A and triangle B. If you look carefully at the sine A plus B formula over here, you're going to notice that, I'm going to write it out in large so you can see it. That's going to be equal to sine A cos B plus cos A sine B. So in order to do this question, we are going to have to figure out not just, we have to use our sine information to find out the other trigonometric ratios in order to draw the triangle. So for triangle A, notice they're not obtuse angles. That just means that it's not in the first quadrant. So I'm going to draw my triangles in the second quadrant because I know sine is positive in this quadrant. So for triangle A, I know that my opposite and my hypotenuse is 3 over 5. Now because I'm going to have to figure out the value of cos A2, you need to use the Pythagorean theorem. C squared is equal to A squared plus B squared in order to solve for the length of the final side. Now, you guys are not in grade 10 anymore. You don't need me to walk you through the Pythagorean theorem. So when you figure out your the length of your adjacent with the Pythagorean theorem, you're going to come up with negative 4 over 5. Same thing with triangle B. I know that my opposite and my hypotenuse, 5 over 13, erase this a little bit. With Pythagorean theorem, you can solve for your adjacent. That's going to be negative 12. So now I have all the information I need in order to plug values into this formula. So sine A, which I already know the value of, 3 over 5, times my cos B, and cos B is going to be adjacent over hypotenuse, so I know that's going to be negative 12 over 13, plus cos A, and cos A, I'm looking at the first triangle, I know that cos A is going to be negative 4 over 5, times my sine of B, which is 5 over 13. So now your knowledge of fractions comes into play. So you have a negative 36 over 65 plus a negative, so it would be negative 20 over 65, which is going to give you a final answer of negative 56 over 65. So that's pretty straightforward. Can I actually just borrow your calculator for a second? I left mine. I'm going to give it right back to you. Okay, so that's one particular test question where we're going to rely on your knowledge of the formula and deriving triangles to come up with the necessary ratios to put into the compound angle formula. Let's do a sine question, because last time I was exclusively focusing on cosine. So if we have sine pi over 12, and you need to express this, use the compound formula to find the exact value of this. So I basically want to express this as sine A plus B or A minus B. Now I know that if you have a calculator on you, if you take pi 180 divided by 12, you are going to get a value of 15 degrees. 15 degrees. So I know that 45 degrees, or pi over 4, minus a value of 30 degrees, which is pi over 6. So those are the special triangles, 45 degrees and 30 degrees. When you subtract those, they give you a value of 15 degrees. So this is going to be my A value. This is going to be my B value. So then, straightforward, you can plug it into the formula. It's going to be equal to sine pi over 4 cos of your B value, pi over 6, subtract, move this down a little bit, cos of pi over 4 times sine of pi over 6. Now on the test, we're always going to draw back to the special angles. We're not going to give you anything more complicated than the special triangles. So, but you do need to know, have a strong knowledge of how to work with radicals in order to solve a question like this. So I did a lot of these in the first seminar. Sine pi over 4 is 1 over root 2. Cosine of pi over 6 is root 3 over 2. Then we have subtract. Cosine of pi over 4 is 1 over root 2. Sine of pi over 6 is 1/2. So when you actually solve those together, you're going to have root 3 minus 1 over 2 root 2. and there's a reason why I wanted to do this particular question. I cannot leave my question like this, my answer like this, sorry, because I have a root 2 in the radical. So what do I have to do to get rid of that root 2 in the radical? What do I have to do? It's called rationalizing the denominator. So how would I rationalize the denominator? Does anyone know? You should know this for your test. Chloe, do you know? Yes, multiply both your numerator and your denominator, not by 2 root 2, but just by radical 2. And when you do that, you get a final answer of root 6 minus root 2. But in your denominator, you have 2 times radical root 2 times radical root 2, which is 4. And that will give you your answer in your denominator. So always, always rationalize your denominator. Now, you can also use compound angle formulas to derive another compound angle formula, which I want to do because it's kind of an introduction. It's very related to trig identities. So say I wanted you to prove that the formula for tan A plus B. So tan A plus B is this formula. Oops, I didn't want to do that. Let's do highlighter. So tan A plus B is this formula over here. So what if your test question asked you to use compound angle formulas to derive the tan compound angle formula? I'm going to show you how to do that. So we know that tan is sine over cos. Tan x is sine x over cos x, right? So we can use that information. Tells us that tan A plus B is going to be the same thing as sine of A plus B over cos of A plus B. Sine of A plus B over cos of A plus B. I'm going to look over here to, and remember you have to memorize these formulas for the test. No one's going to give them to you. So we have sine A cos B plus cos A sine B all over cos A cos B minus sine A sine B, which is equal to, we can kind of break these up into, we can break this up into sine A cos B plus cos A sine B divided by one common denominator. We're going to do the denominator separately. So we have cos A cos B. So first divide both by cos A cos B. This is a little bit complicated, but it is how we derive. Divided by, now my denominator, cos A cos B minus sine A sine B divided by this particular denominator. Oh no, sorry, the same common denominator, which is cos A. Maybe this might be a little too complicated for you guys, but in case you get something like this on the test, it's good to have it in your notes. So what happens is your cos B and your cos B cancel out over there. Cos A and cos A cancel out over here. And all of this, cos A over cos B, that's going to be equal to 1. And what this is over here is just equivalent to tan A tan B. So this gives us that tan A plus B is equal to tan A plus tan B all over 1 minus tan A tan B. So that is a little, maybe a little too challenging. That's more like a first-year university question. but it is a derivation nonetheless. So at least if he gives you something, anything similar, you'll know how to set it up at least. But my fault, so that might be a little too challenging for you guys. But this formula is very important. It's probably the most complicated formula to remember. And I want to show you how we can use this formula. Because it's a more complicated compound angle formula, people run into problems when using it. So we have a lot of time. I want to jam as many questions as we can. And then I'm going to move into double angle formulas after this, I promise. So we're going to find the exact value of tan of negative 5 pi over 12. Tan of negative 5 pi over 12. When you do that, you'll find that negative 5 pi over 12 is negative 75 degrees, which is going to be equal to negative 30 degrees minus 45 degrees. And if we convert that into radians, that's going to be equal to negative pi over 6 minus pi over 4. So again, we're using the special triangles. But because this formula has a numerator and a denominator and there's a lot going on, I do want to walk you through the solution. Even though this part, deriving what to plug into the formula, your angle A and your angle B, is not that complicated, actually using the formula is complicated. So let's start from the beginning. I have tan of negative 5 pi over 12. That's going to be equivalent to tan of negative pi over 6 minus pi over 4. So that's going to be equivalent to tan negative pi over 6 minus tan pi over 4, all divided by 1 plus tan of negative pi over 6 times tan of pi over 4. Now this is just simply plugging it into the formula that we know. Now we actually have to take the values. So tan of negative pi over 6 of negative 30 degrees, that's just equal to negative 1 over root 3. And minus tan pi over 4, that's going to be equal to negative 1. All divided by 1 plus tan of pi over negative pi over 6 times tan of pi over 4. So that's going to be negative 1 over root 3 times positive 1. So when you do that and actually rationalize or have the common denominators, you're going to have negative 1 minus root 3 all over root 3. And I can do the division symbol, but to make it easier, I'm going to write divided by this, and I'm going to solve 1 plus, I'm going to solve for my denominator, which is going to be root 3 minus 1 all over root 3. My biggest tip for this unit is to always write division like this, because it's less complicated, and you know right away when you flip this reciprocal, this root, oops, whoa, don't know what happened there. This root 3, come on, this root 3, when you flip the reciprocal, they're going to cancel out, and let's actually write that so you can see it. I have negative 1 minus root 3 over root 3 times root 3 over root 3 minus 1. So that radical 3 cancels with that radical 3. And now I have to just multiply. So I have negative 1 minus root 3 over root 3 minus 1. However, to cancel, there's a binomial denominator, and this goes back to Unit 7 MCR. In order to cancel out the radical in this denominator, we have to multiply both numerator and denominator by the conjugate binomial. Remember last year, conjugate binomial is you're going to have the exact same terms, however, opposite signs. So instead of a negative 1, this is going to be positive 1, positive 1. And you're going to have to do FOIL with your radicals. So when you actually do your FOIL, in your numerator, you have root 3 minus 3 minus 1 minus root 3. In your denominators, root 3 times root 3 is positive 3. Positive root 3, negative 3, root 3 cancel out, so you have minus 1. Your final answer, negative 4 minus 2 root 3 over 2. But in order to get full marks, you have to recognize the negative 2 and the negative 4, there's a greatest common factor there, which we can take out, back to MCR rules. So if we take a positive 2 out of there, you're left with negative 2 minus root 3, all divided by positive 2. This 2 cancels with this 2. Your final answer is negative 2 minus root 3. And that seems like a very, very long question, but half of that question is what you learned in MCR. Yes, Chris? Yes, I can scroll up. But if that seems like too much, it's exactly your Unit 7 and 8 from MCR from last year, okay? So where do you want me to scroll up to? Yeah, that's good. Oops. So I'll give you a second to copy that down before we move on to the next. Yeah. What do you mean? Where's the 2 root 3? Oh, sorry, this should have been a negative root 3. Take a deep breath. It's just that's the hardest type of compound angle question, okay? So I wanted to walk you through the hardest, because if you have a tan question and you've only been doing sine and cos, you're in for a rude awakening, because tan is just more complicated because there's a numerator and a denominator. That's the only thing that's making it more complicated. Yes, Chris? Scroll down, yes. Okay, let's move on to double angle formulas right now, and I'm going to give you some potential test questions. Okay, so what I'm going to do is give you a soft one, then we're going to move into one that's very likely to be on the test, then we're going to move into identities. So I'm trying to cram as much information as I can for you guys. Please work with me. So here's your first double angle question. Please copy it down quickly. Come on, double angle. Any second now. Oh, there. Okay, no. Bless you. Come on. Okay, for pi in between pi x 2 pi. I don't want to join. Come on. Okay, if cos x is equal to negative 2 over 3, find cos 2x sine 2x. Now, very important, if I look just at the cos 2x formula, I don't have to draw the triangle because it's not enough to know what cos x is. However, later on, I'm going to have to solve for sine 2x, and in order to solve for sine 2x, we have to know both the cos x and the sine x value. So again, I'm using the Pythagorean theorem to generate the side that I don't know, which is going to be negative root 5. So, simple to start off with the cos 2x formula. That's just going to be equal to 2 cos squared x minus 1, which is going to be equal to 2. Remember, I told you last time, cos squared x and 2 cos x are different things. Cos squared x means my cos value, which is negative 2 over 3 squared. 2 cos squared x means 2 times whatever the cos squared x value is. So please don't make that mistake on the test. So I have 2 times negative 2 over 3 squared minus 1, which gives me 2 times negative 2 over 3 squared is going to give me 4 over 9 minus 1. So that's going to be equivalent to 8 over 9 minus 1, which is just negative 1 over 9. So that is going to be the value of cos 2x. Now, looking at that same triangle, my sine 2x formula is a little bit different. That's going to be equal to 2 sine x times cos x. Now, I know that that is 2 times my sine x value times my cos x value. My sine x value for this particular triangle is opposite negative 5, root 5, over my hypotenuse of 3. Cos is negative 2 over 3. When you multiply everything together, you don't have to rationalize the denominator because there is no radical in the denominator, so we can leave our answer as positive 4 root 5 over 9. So from one triangle, we can generate our double angle formulas. Now, something that was difficult in the unit guide, using double angle, it's actually using a combination of double angle formulas as well as compound angle formulas. Use the appropriate compound angle formula and double angle formula to find a formula for sine 3 theta, cos 3 theta, and tan 3 theta. And that's what we're going to do right now. This is actually a question straight from your unit guide, page 408, I believe number 12 and 13 in your unit guide. So for those of you taking the in-class test and have memorized these formulas, they're not going to be that challenging for you, but this is a common test question. So for example, if I want to figure out what sine 3x is, okay? First, I'm going to move to my compound angle, and I know that I can break up sine 3x into sine of 2x plus x. This also is the same thing if it's sine 3 theta. It would be a sine of 2 theta plus theta, right? Now, I'm using the compound angle formula, but I'm also using the double angle formula. Now, first when we use our compound angle formula, you're going to look at this as your A term and this as your B term. So we look at the compound angle formula and we expand this to be sine 2x cos x plus sine now of B, which is sine x, times cos of A, which is cos 2x. That's applying the compound angle part of it. Where the double angle formulas come in, I'm going to take my highlighter and highlight both double angle formulas. And now I have to insert my double angle formulas into that line. This is the same process if I was doing cos 2 theta, which I will show you later on, and tan 2 theta. So this is equal to 2 sine theta, sine 2x, 2 sine theta cos theta. Oh, sorry, not cos theta, cos x. That should be an x. Let's try this again. 2 sine, 2 sine x cos x, again times cos x, which is already in the equation, plus sine x multiplied by the formula of cos 2x, which is going to be multiplied by cos squared x minus sine squared x. So when you do that, you're going to get 2 sine x times cos x is cos squared x. You can put brackets to help you out. Plus sine x times cos squared x minus sine squared x. When you do the distributive property, that's going to be the same as sine x cos squared x minus sine cubed x. And when you combine like terms, you're going to get a final answer of 3 sine x cos squared x minus sine cubed x. Okay. Very similar process when you're trying to figure out what cos 3x is, right? It's going to be very similar process. What I want to work through with you line by line is to find tan 3x, because that is going to be just a little bit difficult. So please follow along. Okay, so starts the same way. Tan 3x is going to be equal to tan of 2x plus x, where your 2x is your angle, is your A, and x is going to be your B value. So this is going to be the same thing as tan 2x plus tan x over 1 minus tan 2x tan x. That's the compound angle formula we're using. But then we have to figure out the double angle formula as well and put it under a common denominator. So we have 2 tan x over 1 minus tan squared x plus tan x minus tan cubed x over 1 minus tan squared x, all divided by 1 minus tan 2x tan x. So a lot of common denominators, that sort of thing. That's how you would set up your equation. Okay, I just realized I'm running out of time. So this question is going to probably scare you and maybe not the best question to do. So instead, let's jump into identities right now, because you definitely need to know identities for your test, and it'll be very sad if we don't touch on identities today. So, yeah. No, you have to keep going. You have to keep going from there, but that's going to take me another 10 minutes, and 10 minutes is not something we can waste right now. So let's go to trig identities. And, well, You can figure it out on your own with common denominators. I've set you up for it, but really have to do trig identities because I've seen the in-class test. You have to know trig identities, okay? Trust me. The important thing is to understand how to set up sine 3x, cos 3x, tan 3x. I don't think he's going to ask you for tan 3x on the test. So understand how I set up sine 3x and apply that to cos 3x, okay? Okay, let's do some identity questions that involve a little bit of these double angle things. Okay, I did that last time. I'm not sure what I did last time and what I didn't, but okay, let's try to do, I want to do a difficult one with you that has denominators in it, okay? So this is a good one. Cos x minus sine x over cos x plus sine x is going to be equal to secant 2x minus tan 2x. So this is like two questions in one because both sides are pretty complicated. So first I'm going to tackle the left-hand side because it doesn't have any double angle formulas. So remember, it's not like grade 10 where you were, or grade 11 where you're only tweaking one side. Sometimes you have to tweak both sides, okay? So the left-hand side is similar to what you've done in MCR. You want to basically multiply by the conjugate. So I have cos x minus sine x over cos x plus sine x times, my conjugate of that is going to be cos x minus sine x all over cos x minus sine x. Now I'm doing that so I have a difference of squares situation in the denominator. So the left-hand side is going to simplify to difference of square situation, so my denominator is simply going to have cos squared x minus sine squared x, and my numerator cos squared x minus sine x cos x minus sine x cos x is negative 2 sine x cos x. Negative sine x times negative sine x is positive sine squared x. But we know the first thing you learned in your MCR course is cos squared x plus sine squared x is equal to 1. So my left-hand side, the most simplified form of my left-hand side is 1 minus 2 sine x cos x all over cos squared x minus sine squared x. Put a box around this because we're going to try to manipulate now my double angle formulas in my right-hand side to get something close to this. Okay? So this is my left-hand side, remember. The simplified version of my left-hand side. Now, if you can understand what I'm doing on the right-hand side, you'll be fine for your test. So my right-hand side is secant 2x minus tan 2x. Remember, this is a very complex identity to prove, the right-hand side. Not the left-hand side, but the right-hand side. So bear with me. I have secant 2x is equal to 1 over cos of 2x. And tan 2x is going to be equal to negative 2 tan x over 1 minus tan squared x. What makes this so complicated is that, remember, the left-hand side is in terms of only sine x and cos x. That means I want to focus in on my tan x's, and I need to convert them into sine x cos x. So much fun. So the left-hand side, 1 over cos 2x, that's going to be equal to 1 over 2 cos squared x minus 1, which is fantastic because my left-hand side did have a cos squared x in it, right? So that's good. However, this side, I'm going to do a side note over here. That is the same as 2 tan x is the same as 2 sine x cos x, right? Then I have to divide all that by 1 minus tan squared x is the same as sine squared x over cos squared x. That looks very complicated. You probably want to do that on the side because that is going to be the same as minus, let's put square brackets over here, 2 sine x cos x divided by this means flip the reciprocal, so it becomes multiplied. Once we have a common denominator here, remember I can take that 1 out and make a common denominator of cos squared x over cos squared x. So the flip the reciprocal means my common denominator of cos squared x is now in my new numerator, cos squared x, and in my denominator I have cos squared x minus sine squared x. To simplify that, I'm going to remain that in square brackets. Cos x can go into cos squared x, cos x times. So that means that this whole expression in the square bracket simplifies to 2 sine x cos x, all divided by cos squared x minus sine squared x. So now we've got past the scary part. If I look back to my left-hand side, so I'm just going to pop up a little bit, I'm going to come back down. My denominator is cos squared x minus sine squared x. So you want to keep that in mind because you have to always look at what you're trying to get. I have a cos squared x minus sine squared x in my denominator right now. So now I have to deal with this 1 over 2 cos squared x. I'm going to change the, oh yes, that's another double angle formula here, 2 cos squared x. So I have to change that now to 1 over cos squared x minus sine squared x, which is going to be equivalent now to, and there's a subtraction sign in the middle, 1 minus 2 sine x cos x, bless you, over cos squared x minus sine squared x, which actually is equivalent to my right-hand side. And the Latin way of saying I have proved this in Latin, the initials for that are QED. So we always put QED after we solve a proof. Okay? So that was a proof involving double angle formulas. Do you want me to do one more? Shorter one? Yes? Okay. Let's do a very short proof. But let's stick with the fractions. It's just going to be much less steps, okay? So I want to prove that 1 plus cos x over sine x is going to be equal to cotangent x divided by 2. Oh, actually, that's a half-angle formula. Did you guys work with half-angle formulas? I can't remember. It's in your unit guide, but okay, forget this. Okay, let's forget this because I don't think he's going to give you any half-angle formulas, so no reason to do that one. Okay, guys, I'm going to show you how to be able to use your knowledge of compound angle to really simplify a proof. So what if you're given something like this? Cos x plus y, cos y, plus sine x plus y times sine y is equal to cos of x. So that looks like a very long thing, but you notice a. If we put x plus y as my a, and this becomes a, and y by itself becomes b, so this is also b. This is the same thing as saying cos a cos b plus sine a sine b. So whenever you see terms repeat, do this. Label them as a plus b, a and b, and rewrite them as a formula, because then you're going to see that this is the same formula as cos of a minus b, right? Where your a term is x plus y, and your b term is just y. And if we actually solve this, so we're kind of going backwards from the compound angle formula. If you solve inside the brackets, cos of x plus y minus y is the same thing as cos x, which is my right-hand side, QED. So that's another trick about identifying compound angle formulas and working backwards. Okay? So I think that's good. I also, if you went to my first part, I did a few more identity questions. But really, if I were you right now, before the test, I don't know exactly what's on the test, but I would go through, based on the test center versions, the sine 3x, the cos 3x, forget tan 3x. Try to understand that whole process, because that's a really good way for teachers to test whether you know compound angle and double angle formulas at the same time. I would memorize my formulas, and don't freak out on your test when you're given an identity. Play with it, right? If one way isn't working, keep going, and do not erase, because your teacher can give you part marks at least for whatever work that you're showing. So even if you hit a dead end, don't erase it, just draw a line and try again. The more steps that you have, the more ways you try it, the more marks we can possibly give you, okay? So good luck to those of you writing the test this afternoon. I'll see you later.